This is Mr. Abling here, coming out with part 2 of the 6th grade midterm study guide. So we left off right as Billy was designing a 3-foot tall wooden house, and as we found out, poor Billy, his cat couldn't scratch against the smooth wooden walls. So kind of did not meet one of his criteria. So poor Billy. So that's where we left off. But hopefully in that last one, Billy optimized his solution so that his little kitten could scratch the little sides of the wooden wall. All right, that's kind of half the point of building little cat towers. They can scratch the little thingamajigger. All right, moving on. Ooh, speaking of optimizing, it might come in handy here. Okay, so before we get started, all right, what I would have open if you're following along, and I would imagine you're following along because you're watching this video. So what else you'd be doing? So you're like listening to it while you're working out or something on a treadmill. Okay, kind of cool. Pumps you up a little bit. I'm going to open up this link right here. This is the design process steps. So anytime it asks for like, what steps has Billy done? What steps should they do next? These are the steps that I'm going to refer to. So having this open, even bookmark this bad boy. Add bookmark. Okay. You know, it's always good to have that ready to go. So I'm going to have that ready to go, and hopefully you have it ready to go too. So, all right. We've moved on from Billy, though, so hopefully Billy's cat is happy. I'm assuming he is. Maybe I'll rewrite the question next year, so Billy's cat scratching that post. Right, he's optimized. Oh, an emergency equipment company makes warning signal flares. The company wants to redesign a flare so that it produces light for a longer period of time. All right, after the company thinks of ideas, what are the next steps in the design process? So, want to redesign a flare that produces light for a longer period of time. So what's happening there? We've evaluated the flare. We have determined that the flares don't meet the criteria that we want. So we've tested the flares. Okay, so looking at our little chart of joy. All right, they've already had the prototype. They already have the basic flare. They performed a test. They evaluated and turned that it doesn't stay lit for enough time. So they've already evaluated. So where do we want to go after we've evaluated? We want to optimize and improve that design, I'm going to guess. Let's see if that works for us. All right. If the company thinks of ideas, what are the next steps in the process? Yep, we want to optimize. We want to optimize the flare. Optimize the flare. Okay. Okay. Evaluate after evaluating the results. So there you go. You're going to get questions like this, okay? Predict what's the next thing we should do. And remember, I know I'm kind of recapping a little bit, so if you just watched part 1, you can kind of review a little bit. You don't have to memorize each step necessarily. It just kind of makes common sense, okay? You build your prototype. You build the model. You build it. You test it, okay? You see if it works or not, which is evaluating. Okay? And then if it doesn't work as well as you want it to, you fix it. That's optimizing. So it's not like hard steps to memorize. They go in common sense, which is wonderful. Makes it a lot easier. Okay, so just common sense your way through these. It'll be a lot easier than trying to think, okay, what's step 1, what's step 2, what's step 3. Just think about it in a very generic sense, and you should be fine. Alrighty. Ooh, we got Kinsley and Sebastian. What are we doing here? Ooh, a science fair. It's exciting. We're gonna have a science fair in the spring, I believe. So, all right. Their plan is to design a water filter using only a water bottle and natural materials found in or near a local stream. Question might sound familiar. I think it's from a homework. All right, so just looking at that, only natural materials found in or near a local stream. So that would be a constraint, in case you're wondering, that's preventing them from building it however they want. They make a crude filter. What's crude mean? Crude means like simple, like basic. So that's kind of going to be like our prototype. So making a crude filter is like making a simple version. Okay, so we're building our prototype. All right, so predicting ahead. I've built my prototype. Looking at my little steps of joy. Ooh, we should probably test out this filter. That's what I'm going to predict they do next. If they don't, Sebastian needs to work on his engineering design steps. Okay. And sand in the water bottle. Kinsley and Sebastian then pour stream water through the filter and analyze. So now they are testing and analyzing. Okay. This filter water with a microscope. They find that while the filter removed dirt and piece of plant, it did not remove all of the bacteria. What step should they do next? All right. So this is going to be optimizing again here. Okay. We're optimized. So it did not work as well as planned. You can tell I'm focusing a lot about optimizing because I found that we mixed up evaluating and optimizing quite a lot. So we've got some practice here. Okay. All right. So there we go. Optimizing. It did not filter the removed dirt as much as it wanted. So they should probably do it again. Okay. So the evaluated, next step is optimize. So you can tell there's going to be a question about optimizing on the midterm. So we're really trying to hammer that point home here. All right. Here we go. Read the passage below. This is right off IXL. Okay. So what I really recommend is practicing these links. Okay. Um, the those are the ones for that one. Okay, we have them. Okay, I have those ISL. I'm gonna go look for it now, but all right, they're there. I'll go link it again here for you, just in case, just some more practice. Okay, we've practiced those a lot, but I'll go post it up again. They're on the Monday materials. All right. Anyway, read the passage below. Highlight or change the font of the sentence that shows the criteria as red. So basically, identify that criteria and just put it as red. Okay, any kind of font or highlighting is red. A little practice there on how to modify a Google Doc as well. And we want to highlight or change the font of the sentence that shows the prototype as yellow. So we're looking for criteria and our prototype. So let's check it out. The mayor of Centerville, right, has received many letters from residents who are unhappy about traffic on the main highway. That sounds awful. Okay, it sounds like a rough situation, angry traffic. Okay, so that's a problem. Okay, so if you look at the steps here, we've probably identified the problem. Angry traffic goers. That's always a problem. All righty. She assembles a team of engineers and they investigate traffic flows and come up with some possible solutions. So that sounds like brainstorming. Okay. All right. The team proposes adding more lanes to the town's busy overpass. Okay. So they're suggesting some things. The mayor says she will support the project only if it reduces commute times by at least 10 minutes and costs less than $300,000. So what we have here is commute times. Okay, so it needs to reduce commute times by at least 10 minutes. Okay, so that would be the best thing. So I said criteria as red. All right, so that would be our criteria. Now, a lot of you probably highlighted and cost less than $300,000. A lot of you probably highlighted that as well, potentially for criteria. But let's go back to our help link here. Okay, and if you haven't watched part one, this would be not going back. It's the first time we've clicked on it, but it comes up a lot in part one. So criteria are rules that must be followed. They're the requirements that must be met. So reducing traffic time by 10 minutes, I believe that's what it said, right? Reducing traffic time by at least 10 minutes. And the $300,000, that sounds more like a constraint. So are the restrictions that keep something from being the best that it can be. So constraints limit how you solve a problem. Okay, so a lot of times that's time and money. So when you see it can't cost more than a certain thing, it's more of a constraint. Okay, so if you highlighted cost less than $300,000 in red as a criteria, that's not bad. But if I were to ask you to say, does that sound more like a criteria or a constraint? Probably want to say that sounds like a constraint more than a criteria. So, all right, there you go. Oh, and we want our prototype. Okay. All right. So, all right, we're proposing ideas. Proposing an idea is not building a prototype yet. We've identified what the prototype needs to do, and that is reduce commute times by at least 10 minutes. We haven't built a prototype yet. So the engineers draw up a plan. Those are some good keywords for prototype. So drawing up a plan, building a model, creating a test version, little keywords like that will help you find a prototype. So the engineers draw up a plan for the new lanes, including estimated costs of the project. So drawing up the plan. Yeah. So that is going to be our prototype. So it says highlight or change the font. So to do that, change the font here. That's that. Or you can highlight. That's this little guy right here. Okay, boom shakalaka. Either way is fine. All right, as long as you know what the answer is, good to go. You marked me wrong if I used the wrong shade of yellow. No, that's pretty horrible. I don't think I would ever do that to you. So, little Google Doc practice. All right, moving on. Number 8. Okay, number 8. Let's see where we're at here. Still on the engineering design process. What step design process is highlighted below? You will definitely get a question just like this on the midterm. It will not be Jake working for a company. It'll be another one off the IXL. Okay, we'll go over where to get that here, that IXL. So go to your midterm review. Okay, that's going to be Tuesday review materials. Open that bad boy. Okay, remember, if you missed where I clicked on that, okay, oh, there it is, IXL design process. I think it was on that thing. Now that I think about it. All right, there we go. This is really, really useful. All right, sign in there. The SIG Prep equals, right? Click teacher. You're a teacher today. All right. This is really useful. So what I do is I just take different examples of these and make questions off those. So if you know how to do all the ones in here, you should be just fine. So that's a great way to practice for the midterm. All right, back to where we're at here. All right, what's up? Design process highlighted below. So we got Jake works for a company that builds wind turbines. Sounds kind of cool. Lately, birds have been getting injured by the turbine blades. Okay, so that is probably identifying the problem. Looking at our steps of joy. Yeah, okay. Birds running into the wind turbine. Those are those big like windmill things. You don't want to get caught in a wind turbine. That's going to be a bad day, whether you're a bird or a person. So, yeah, getting caught in a wind turbine, we've identified the problem. I'm pretty sure about that. Little birds have been getting injured by the turbine blades. Oh, poor little birds. We don't want that to happen. Jake's team is considering using radio transmitters that make sounds to warn the birds and steer them away from the dangerous blades. So, like some horrible noise. I hope it's not too annoying other residents, some screeching noise. Jake would like to find out which type of transmitter is most effective, so he attaches each type to a different wind turbine and notes the behavior of nearby birds. Okay, so he's trying to figure out the best solution to his problem. Okay, so he is attaching different wind turbines. He's already come up with the idea of the radio transmitters, so that's kind of like your brainstorming. So this is kind of like our prototype, and we are actually in the process of testing it. So the attaching each type to a different wind turbine, that is testing to see if these radio transmitter works. So I would consider that right here. Let's see. Performing test and evaluating results. Okay, and I would say performing the test right now, because the next one sounds like evaluating. So I would say performing the tests. Right, performing the tests. The next step, after collecting all of the results, he looks over his notes to determine which transmitter was most effective. That is evaluating. Okay, so we've got testing, which is the highlighted one, and the one after that is evaluating. All right, good stuff. Okay, number 9. Okay, this will look familiar. We had this question on the test, and it's good practice. Okay, it kind of gives you a lot of opportunities to identify criteria and constraints. So let's have at it. So I wrote this one up for you guys. All right, so everything in yellow is either going to be a criteria or a constraint. So let's go back to our handy dandy chart. Where did you get that again? Where it says help link. Right there, I would have that guy open, okay? So when you're doing the study guide, try not to just guess off the top of your head. Go back and reference these documents as you're doing it. So let's say you're reading this and you get to that first highlighted thing, okay, and you're not sure, you forget what criteria constraint are. Use this. This will really help you build the knowledge for when you take the test. Okay, you get it down so you're not just guessing and hoping you're right. Okay, you still might do that, but give you a better chance of getting it correct. So let's have a look at it. A software engineer design team that works for the company Carltopia. Carltopia is not a real country or a company. Sounds like a cool country, like Carltopia. But I made that up. So before you Google it, there might be something there, but I made this up. Tech company Carltopia has been tasked with creating a new app that needs to be ready for testing by Christmas. Okay, so our first thing is needs to be ready for testing by Christmas. So ready for testing by Christmas, criteria or constraint. Let's go ahead and look at those again. So criteria are the rules, directions that must be followed. So basically, the model has to be able to do this. Constraints are restrictions that keep something from being the best it can be. They can be problems that arise, issues that can come up. Right here as well, constraints are factors that limit how you can solve a problem. So the model criteria isn't ready for Christmas. That is a limit for how you design your model. So We're going to call that a constraint. Okay. So you only have a certain amount of time to do it. That is constraining you from building your best possible model. Alrighty. The company told them they wanted a phone app that allowed the user to find a movie to watch based on how they were feeling or what they were looking for in a movie. Okay. So it has to be a phone. Okay. It has to be usable on a phone. That would be a criteria. Okay. If it's only usable on a computer or a Chromebook, okay, that doesn't meet the criteria. So it has to be able to use on a phone. So we're going to call that a criteria. Okay, Carltopia told the head engineer Billy Billington, great name, Billy Billington. He's probably awesome at life. The user should describe what they want in a movie, and the app gives them a list of the top 5 matches. Okay, so that is, I don't have a question on here for that, but might as well use it. Okay, a list of the top 5 matches. It needs to provide that. That's a criteria. So I'll give you guys a little bit of a break. I didn't put as many questions in there, so there you go. But it's free on the review video. So that's a criteria. That's something the phone has to be able to do. They will need ability to make a code that has to be compatible. Okay, usable is another word for compatible by both Apple and Android. So the software has to be able to use on an Apple device and a Android device. So that is a criteria. The model has to be able to do that. Okay, so it has to be compatible with both Apple and Android. That's a criteria. Kind of sounds a little almost like a constraint, okay, but it's more of a criteria. That's probably the hardest one, I think. No collaboration with Apple team. So it's telling you can't do something. Okay, something that says you can't do this, usually a constraint. But let's see. All right. The Cartopia Apple team is busy. That's a problem. So, normally they might be able to collaborate with them. That's a good thing. Like help them with the Apple, platform. But they're busy. So that's a constraint. That's one less resource they have to build this app. So no collaboration with Apple team. Oh man, that's gonna be a problem. Now we gotta work harder without the experts on Apple. Boom shakalaka. That's gonna be a constraint. Okay, so he will not be able to collaborate with them on the app. All right, they don't want a large app, so it needs to be less than 12 megabytes of data. Okay, that there would be a criteria if it asked for it. Okay, which will result in, we're going to use that later here in a little bit. We'll get to that. Result in slightly slower speeds. Okay, Carltopia has given Billy $50,000 to research and build the demo version of the app. Okay, so $50,000 to research. Okay, that's not something the model has to be able to do. So that is a constraint. It's basically saying, oh, we got this great plan to build a software app. It's going to cost $1 million. Well, we don't have that option. We are constrained by the $50,000. Might seem like a lot of money, but who knows? Okay, they only have a limit. So if it costs $60,000, they have to redesign their model. So that would be a constraint. Okay. Okay, so pretty good practice there. Okay. All right, we have one more thing here. In the above paragraph, there is a trade-off made by the company. What was that trade-off? I don't know what a trade-off is. Ooh, I have a link here. Let's see if it was a good. A good link. All right. Okay. Ooh, introduction to engineering. Ooh, trade-off, design and trade-offs. Right here. Ooh, in bold, nice. When you need to choose between 2 or more alternatives, a trade-off is necessary. A trade-off typically means you need to make a compromise. Something is gained while something else, okay, needs to be given up. Okay, so we want to look for something in the paragraph above where you get something, but you have to give something up as a result. So let's see if we can find one. They want a flow that allowed the user to find a movie to watch based on how they were feeling. They're looking for a movie. No, we're not giving anything up here. They want a movie with the top 5 matches. Don't have to give anything up. Has to be compatible by both Apple and Android. No, we're not giving anything up as a result of that yet. Where I want to focus down is right here at the bottom. So they don't want a large app. Okay, so their priority is size. Okay, that's the most important thing to them is they want it small. It needs to be less than 12 megabytes of data. Okay, that's fine. But that is going to result in slightly slower speeds. So they basically determined that it's more important to be under 12 megabytes than it is to be slightly faster. So maybe making a larger app is going to allow it to be a little faster with a little more data. But according to this, it's more important to stay under the 12 megabytes than it is to be a little bit faster. So that is going to be a trade-off. So I'm just going to copy and paste that in right here. Boom shakalaka. All right. Yeah. You said not copy and pasting. Yeah, sometimes I do say that, but sometimes it makes sense. Okay, if it's right on my document, I usually just don't want you to go to Google, copy and paste off Google, because who knows what you're copy and pasting. If something I give you, a little different there. Okay, copy and paste a lot. It's efficient. Just copy and paste things that I give you, because that's what I want you to be putting in there, not something randomly off Google is what I probably was talking about. But yeah, that's a trade-off. Okay, so you get a question just like that. Okay, it won't be this exact one, but just think, okay, I get one benefit, but it comes at the expense of something else. All right, so that kind of wraps up engineering design, but it's gonna gotta keep on rolling here. I'm gonna keep on rolling. All right, define each of the following. Okay, these two words, super important. Okay, I just want to take a moment of zen. Okay, that independent variable, dependent variable, super duper, that's two, right? Mooper, flooper, grouper, looper, drooper. What else can I do? Plooper, important words. Okay, like knowing these two things is really important. You can see independent kind of easy maybe to mix them up. So hopefully we can get that. So just really force yourself to remember it. If you only remember two words, well, criterion constraint, okay, criterion constraint, independent variable, and dependent variable, your four most important words to just memorize in your brain. Okay, sometimes you just gotta get things in there, and it can be hard sometimes, but that's what help links are for. All right, so let's go ahead and open this up here. All right, hopefully I got the right link. I do. All right, this one's pretty good here. Okay, so now we're switching over to the scientific method. So it's kind of a pivot. Okay, a little bit of a pivot. This kind of way it worked. Maybe I'll do it separately later, but we're going to pivot into scientific method. So, okay, scientific method is basically now we're testing for knowledge. We're setting up an experiment to try to learn something. Okay, so let's just get these in here. Independent variable. Amount of fertilizer is independent variable because it was the variable whose effect you were investigating. This type of variable is called independent variable because it does not depend on what happens as the experiment begins. It said you decided to give the fertilizer to some plants to others. So, right here in the picture is nice. So this is probably the best definition to use from this link. I like pictures. I'm a big fan. Be a little bigger there. All right. Yeah, don't have to fit on the same slide. Independent variable is the one thing you change, okay, in an experiment. Okay, you should have one change to an experiment. So why don't I put a nice definition in here? So we'll call it the one, not only one, there can't be two, one thing you change in an experiment. Autocorrect, yes, to answer your question. All right, so going back, we did that plant growing lab, virtual lab. Okay, I asked you guys to like change the amount of water the plants received. Okay, to see if changing the amount of water helped the plants grow more or less, or changing the amount of light to see if that helped the plants grow more or less. That would be your independent variable. Actually, not a bad idea to pull up that growing plants virtual lab. So bear with me here. I think that'll be useful. All right. There we go. Boom shakalaka. Beautiful. Okay, so our variables. So let's say I wanted to I want to see if changing the amount of water is going to affect how high the plants grow. Okay, so we're going to give everything a tomato seed, right? You guys doing good, by the way, over there. Doing good. Appreciate that, so fair. Nice. Tomato seed. All right, so we want to change the amount of water. So we want everything the same. So let's give them all two things of light. Okay. All right. And we'll give this one, oh no, no water. Oh my goodness gracious. Okay. Okay. So I'm answering to see if more or less water is going to help the plant grow. So I've got different amounts of water, but everything else is the same. That is what I changed. I changed the amount of water. So for independent variable, think to yourself, I changed this. Okay, what did I make different? In this case, it is the amount of water. I changed the amount of water to see if it's going to affect how they grow. That's what your independent variable is. It's the thing I change, I make different. The only thing I made different right now is the amount of water. Okay. That's the I part. That's the best I can come up with to how to remember the independent variable. It's not bad. It's not bad. It's not great, but it's the best I can come up with after 10 years of doing this. Dependent variable. Okay. So it's kind of like, Mom, can I go to the zoo this weekend? Okay. Well, the zoo's in Vegas. Well, it depends on if you do your homework or not. So whether or not you go to the zoo depends on something else. That's kind of your dependent variable. It's what you're measuring to see if your independent variable works. So if I want to see if changing the amount of water in my independent variable is going to determine if the plant grows more, I'm going to measure the growth, okay, and how much they grow should depend on the amount of water. So in a nutshell, dependent variable is the change that happens because of the independent variable, okay, in a nutshell, just remember it's what you measure. Okay? I'm going to put it's what you measure, what you are measuring at the end of your test. Okay? So if I'm testing to see if the amount of water changes the height of the plant, how high it grows, I'm measuring the height of the plant. Okay? So in this case, okay, I'd be letting it go. All right. This is always exciting to watch these plants grow. Oh, there we go. It's always better to do this virtually. Like doing this for 20 days, a 20-day video would be pretty awful. So my dependent variable would be my data, and that is the height of the plant. So in this case, the dependent variable is the height of the plant. So the independent variable is the thing that I change before the experiment. Dependent variable is the thing that I measure at the end of it. Okay? All right, what is the control group? Okay, a control group, right? That is the test. That's the part of the test, okay, that you're using to compare your results to. Okay, so it's the thing that doesn't get the independent variable. Okay, so we'll put the comparison test doesn't get the independent variable. Doesn't get the independent variable. Independent variable. All right. So let's go back to this. Okay. Let's make everything the same here now. All right. Oh, I gotta restart. I do believe. Okay. So we want to give them all the same water now. Let's give them 50. Now let's say I think I predict my hypothesis that adding fertilizer. Okay. Adding fertilizer to a plant, a tomato plant, is going to help it grow more. Okay. So I run the test, right? All right, and I'm seeing. Now, how do I know that adding fertilizer makes it grow more? Well, the obvious answer is I want to have a plant without fertilizer that I can compare it to. So right now, the plant that has the fertilizer is growing more than the plant that does it. But if I don't have this group, okay, if I give them all fertilizer, all right, if I give them all fertilizer, now I don't know if the ones with fertilizer grow more than the ones without it. So that's why we have a control group. Okay, your control group, okay, is the comparison test. Doesn't get the independent variable. If I want to say that, oh, students that got a review guide should do better than students that don't get a review guide, I need to have that group that doesn't get a review guide. Don't worry, everyone's going to get a review guide. You're not going to be the control group for that. But yeah, students that get a review guide do better. Okay, well, I need a group that doesn't get the review guide. That's my control. Okay, and constants. Constants are things that are the same in every test. Okay, things that are the same in every test group. Okay? So if I look at this, oh, I'm inside of my own gizmo. Hold on, see if I can do it real fast. Good job, Carl. Come on. Yep. Uh oh. Carl expired. Okay. I guess I'll have to go back and fix that. But if you look at it, like the same amount of water. So I just wanted to see if the fertilizer made it different. It's like the same amount of water. Okay. The same amount of light bulbs. Okay. Those make sure it's a fair test. So we watched that Mythbusters with talking to plants, for example. They all got the same pop, all one seed in one pot. The only thing that was different, okay, was the type of sound, music, or talking that they got. All right, I'm going to go ahead and stop here. This will be the end of part two, and should do one more with part three. Ooh, we're almost there. So now we're going to apply these vocab words to different problems. So, all right, if you enjoyed that one, and I'm going to peace out of here. Boom, shakalaka.